This short video will explain the process of eosinophil activation by a parasitic invader. We begin with the innate immune system and our antigen-presenting cell, which presents the process antigen on its MHC2 receptor. Next, we have our CD4 T helper cell coming along. This will interact with the MHC2 and the antigen and use its specific T cell receptor to bind to the antigen. The T helper cell will go on to release chemokines. These will include CCL5, 7, 11 and 13. This will lead to inflammation of the area. In addition to these chemokines being released, some leukotrienes will also be produced. One of particular significance is IL-5. IL-5 will enter the bone marrow, stimulating production of eosinophils. Eosinophils are relatively rare in the blood of a non-parasite infected individual due to the toxicity of their granules and therefore their ability to harm the host. Chemokine CCL11 will bind to the CCR3 receptor on the eosinophils in the bone marrow. This will lead to their migration into the bloodstream. Now we'll take a closer look at eosinophil action in the blood. Chemokines produced earlier by the CD4 helper cell have now caused inflammation, and this is where the eosinophils migrate to. As we can see, some antibodies are already bound to the parasite, and so it's clear that there will be some antibody-dependent cellular cytotoxicity involved here. The chemokines stimulate eosinophils to express two main receptors. These are Fc gamma receptor 1 and Fc epsilon receptor 1. These receptors can now bind to the IgG and IgE antibodies already bound to the parasite. The binding of the Fc receptors to the antibodies will cause the eosinophil to release its toxic granules. This will result in eventual death and removal of the parasite.